In this problem, we're modeling how fast the bacteria population is growing, and we're given that the initial bacteria count is 47 million. Also, 7 hours later, the count was up to 90 million. We're to write an exponential equation that models this scenario, and we're allowed to round the value of b in our equation to 4 decimal places. Those being the ground rules, I'll start with the model y equals ab to the x, although I'm going to change the variables to help us remember which variable represents time and which one represents the quantity of bacteria in our story. So rather than using the output variable y, I'm going to use the variable q for quantity, and since my input variable x represents time, I'm going to use the letter t to remind us that the input variable is time. Now the value of a in our exponential model is what we get out when our input is 0. Since our input variable is time, times 0 indicates what's happening initially. So this gives us that a is 47. To illustrate this, it was given that the quantity of bacteria was 47 million initially. So if you let t equals 0 represent the starting of the experiment, since our non-zero constant b to the 0 is 1, we get that 1 times a is a, and this leads me to what I said earlier, that a is what you get out when you replace the input variable with 0. Now, knowing that a is 47, I can replace a with 47, giving me a more complete model. So replacing a with 47, I get that q is equal to 47 times b to the t. Now to find the value of b to 4 decimal places, I need an ordered pair for another time and quantity. I was told that after 7 hours, the quantity of bacteria was 90 million. Since I'm thinking of my output variable as being in millions, I will replace q with just 90. So a general point, t comma q, on my model has t being in hours, and q is the quantity of bacteria in millions. I was told that t equals 7 hours, the quantity in millions of bacteria was 90. So now I can replace q with 90 and t with 7 in this equation and solve for b. First, by noticing that the 47 is being multiplied by b to the 7th, so I will divide both sides of the equation by 47, and since 47 divided by 47 is 1, that simplifies out as 1 times b to the 7th. Then, one way to solve for b, since it's being raised to the 7th power, is to simply raise to the 1/7. Exponent rules say that the 7 gets multiplied by the 1/7, and 7 times 1/7 is 1. This would leave me with b to the 1st. So I have solved for b. But if I raise the right-hand side of the equation to the 1/7 power, I must raise the left-hand side of the equation to the 1/7 power as well. So as I stated, since 7 times 1/7 is 1, you have b to the 1st power here, and there's no need to write the 1, so I've solved for b. Now I just need to take a calculator and take 90 over 47 and raise to the 1/7 power, being careful on the calculator to put parentheses in the appropriate places. So for example, I want the entire quotient 90 over 47 to be raised to a power, so I put it in parentheses. I'll use the caret key, and since I want the fraction 1/7 to be the exponent, I need to put that in parentheses as well. So to get a 4 decimal place approximation, I type this into my calculator, and to round to 4 decimal places, since the digit here is 5 or higher, I will round the 2 up to a 3. So my b value to 4 decimal places is 1.0973. So I will go back now to the most complete model I had. This is the model we had after finding the value of a. Now that we know the value of b to 4 decimal places, I can simply substitute b with that number now. So my equation would be q equals 47 times 1.0973 to the t power. If you want to express this answer in function notation, you should write your output variable as q of t. If you were asked to represent your answer with the original variables of x and y, you simply could go back and use y instead of q, and use the variable x instead of t, and you'd have your answer in the form y equals ab to the x with b to 4 decimal places.